I'm going to be talking about what I've been doing in my personal projects as well as lead Android engineer for Discovery. But first things first, the release of ARCore happened earlier this year. Google released ARCore with a suite of companion SDKs and features. One of these were Augmented Images, which in my opinion is the coolest feature so far that's been released. And Sceneform was also a companion SDK released with ARCore that really helps with just building AR experiences in general. So if you're not familiar with what an augmented image is, I keep wanting to call it AI. An augmented image is essentially a feature that allows you to respond to 2D images such as posters and product packaging and things like that with a 3D experience. So simply put, augmented images work by providing a set of reference images to ARCore. And then ARCore then tracks these images' physical location in the AR session once it's detected. So the easiest way to accomplish this is going to be to use Sceneform. But if you guys aren't familiar with what an augmented image is exactly, here's an example. So this is Google's example. It's also a really good example as well. I promise it's a lot simpler than what it looks like, but it does involve the prior two dependencies I talked about, both Sceneform and ARCore. So first I'll go over ARCore. So there's been a big push with AR recently, mainly with Apple and Google. Apple released ARKit around this time last year, and Google followed with its pre-1.0 version of ARCore. And that's pretty much where I had my introduction to ARCore. I was fortunate enough to be a part of the early access developer program through Discovery, and we were tasked with creating a feature for their game developer conference that was coming up. So we created a feature called AR Cupcake. This is what that feature looks like pre-1.0. Or pre-1.0 of ARCore. So essentially it's just a feature that allows you to create a cupcake, a virtual cupcake, add wrappers and liners to it with the whole purpose of being able to share that cupcake. One of the cooler features of ARCore is that you can actually screenshot an AR session. So it's really easy to just grab a photo of what's on the screen and send that to someone. So it's going to be easier to create and understand augmented images if you understand what's actually going on under the hood with ARCore. ARCore works off of three main principles, the first being motion tracking. So at this stage, ARCore utilizes concurrent odometry and mapping to understand the world through the camera or through your phone's camera. And then it does this to be able to better identify feature points on objects, as you can kind of see depicted on the image here. And with this, it estimates its pose, or what's known as its position and orientation of the camera relative to the world over time. So combining all of this is able to render your 3D objects. So in layman's term, what this means is that there's a virtual real camera illusion going on. You have to kind of train ARCore to know what's going on inside of the real world so it can build its understanding of the world and create a virtual world where your actual objects are placed. This is why you may see some jumping around or inaccuracies when you're placing your objects. This is because ARCore hasn't, or it's not super accurate as far as its understanding of the world. But the good thing about it is that ARCore constantly builds on its understanding of the environment. And at this stage, it tries to identify planes by connecting these feature points. So obviously, if a couple of feature points seem to lie on the same plane, it's going to try to connect that and say it's a plane. It still sometimes isn't super accurate. It might have diagonal planes or something like that. But all that being said, what does this mean? So there's a good and bad to this. The good is that with proper lighting, ARCore is going to become way more accurate, and your AR experience should be pretty seamless, much like what you get when you use the AR experience inside of your camera if you have a Pixel or anything like that. The bad side of this is that flat surfaces, any surface without texture, homogeneous environments that are the same color, things like that without contrast, this is going to not be detected properly. And bad lighting is especially very important because that affects the light estimation, which is the last strategy that ARCore uses to kind of increase the realism of your AR experience. So ARCore can detect information about the lighting in the environment. This is not something that we had pre-1.0, but it's something that Google added after 1.0. And all this means is that as you're panning your camera, it's also getting light information so that it can give an average intensity of the light. As you can see depicted on this image, if you place two AR objects, one in a shaded area, one in a lit area, then it should be lighted appropriately. So that being said, it really depended on the file types and your the actual how the object was created inside of your 3D creator. We used Blender, so we were exporting to a certain file format, which was wavefront, and this did not, and we didn't really include lighting inside of our files when it was pre 1.0. So a lot of our images when we first were testing with it, or our AR objects when we first were testing with it, wasn't really lit appropriately, but thankfully we have that now. So you'll see a lot of these file formats come back, for instance, from Poly, if you've ever used Poly. Poly is a website that Google released that pretty much just hosts AR assets and creations. It's 100% free of charge. You can use it to host your AR assets, or you can just view others' AR assets and use them as well. They are licensed, so make sure that you have you give the creators credit for that. You can even access it through an API, which is super helpful, so you don't have to add those models into your app, which is really, really heavy. And it's a good inspiration if you're not a 3D creator and you're just an Android engineer like most of us, trying to create an AR experience. So the hardest part of actually creating an AR experience is creating a 3D object. And I would say secondly is utilizing ARCore. This is because ARCore is a very base layer to the whole AR infrastructure. It's pretty much just like turning on a switch saying that I want to be able to do AR stuff in my app, but it doesn't make it easy for you to do that unless you're really good at like OpenGL and things like that. And it was even harder pre 1.0. So they created Sceneform to kind of mitigate that. And Sceneform, as I mentioned, is a companion SDK that just makes it a lot simpler to create AR experiences. It's based off of a scene graph API, so that just pretty much means it's based off the concept of nodes. And it's at version 1.5.1 right now, so it's progressing pretty steadily. You don't have to use Sceneform. We didn't at the Food Network. We used a competitor called Vero, which is a lot more mature than Sceneform. It was out before Sceneform, and it even has a lot more features than Sceneform. There's also another third-party library called Vuforia. I don't know if you guys are familiar with that, but it's also pretty popular, which kind of does the same thing. I would definitely recommend checking it out. Vero is really powerful, so you may not need it, but Sceneform is native, so I would say that in due time, Sceneform will probably be the solve-all for a lot of the AR issues that come up. But that being said, it was such a problem, I would say, or such a barrier to entry for engineers to actually create AR experiences. We were complaining about it back when we were talking with Google trying to create the AR feature. And I just thought it was funny that this is the first sentence on their Sceneform documentation. It's very straightforward. Pretty much it just says that Sceneform makes it really straightforward to render realistic 3D scenes in AR and non-AR without having to learn OpenGL. Like I mentioned, you had to be really, really experienced in OpenGL to do AR stuff in Android before Sceneform. It includes a lot of helpful things, but one of the things that I want to point out that it includes is it has its own physically based renderer, or what's known as a PBR, provided by Filament. And Filament is a library also provided by Google. If you haven't looked into Filament, please do so. I'm just going to touch on it really quick. What it does is it just adds a physics touch to your AR objects. And Sceneform, of course, is utilizing this, so you can do this with Sceneform to kind of make your objects look a bit more real. You can even see, if you zoom in on this Death Star here on the right, the reflection of the room on its skin, so to say, which is really impressive because I know how hard that is to do. There is a plugin that goes with Sceneform to kind of make it easier on us to modify AR objects inside of Android Studio. This is relatively new. It's called Google Sceneform Tools. It's currently in beta, and it pretty much just allows you to import, view, and create 3D assets. It supports many different file formats, much like ARCore at the moment, and you can find the plugin on the plugin browser, Android Studio. All right, so now that the background information is done, let's just jump into augmented images. So there's three key components when dealing with augmented images that I've seen in my experience. I tried to summarize this as much as I can, but there's going to be the UI component, the model renderable, and your node. So first things first, the UI component is comprised of the AR scene view and the AR fragment. The AR scene view is your surface view. It's pretty much that virtual camera, real camera pair that I was talking about. It's a surface view with a virtual camera surface view compatibility with it. And this allows you to, of course, render objects, but it also allows you to see feature points and even highlight planes that ARCore is understanding. So it's super helpful. One caveat to this is that it doesn't handle your permission checks and runtime ARCore checks for you. So you definitely want to take a look at AR Fragment, which does this for you out of the box. All you have to do is add it to your view. And it's going to automatically request if ARCore is installed, what version it is, if you have the camera permission, and things like that, to the point to where if you wanted to kind of customize this, you could extend from AR Fragment and handle the exceptions itself. So here's what this looks like under the hood. All right, so base AR Fragment is actually what makes the requests and handles all the, the flow of the permissions and making sure that the app or the phone is compatible for ARCore and the user, has given you permission to do whatever you want. Here's the exceptions that are all the exceptions that could be thrown at this point. Of course, you can override it and handle it as you will, but this is just what's given to you using AR Fragment. All of these, again, you can extend from all of these and kind of just make your own, just to give a little bit more customization. And you're going to need the AR scene view, which the AR Fragment utilizes for the next step, which is adding the renderable that your model renderable renders to that view. So the model renderable is a very important object as far as augmenting images are concerned. There's many different ways you can set a source. You can set a source from an asset ID, as I'm doing right here, or you can use an input stream or URI just to make it a little bit more dynamic. You can even use what's called a renderable definition, which is essentially an object that allows you to build an object, programmatically. I don't know if that's up your alley, but it's definitely not up mine because it definitely takes a lot of time to do that. So this model renderable is going to allow you to load a renderable from a certain path, and it's going to return that renderable so that it can be rendered on screen. It's a lot of renderables. This build function right here is really important in that it's going to automatically load the 3D model on a background thread for you, so you don't have to wrap this in any type of RX function or put it in the background thread itself. And it's going to then return a completable future. And if you guys aren't familiar with completable futures, it's really flexible objects. They're really powerful. But as far as augmented images are concerned, you just want to remember to call then accept, handle, or check if it's done loading before you call any version of get, because if you do so, you're going to get a null. And of course, that's not going to be good. I could go into detail about what all these different functions do. But then accept is probably going to be the one that you use the most because it's the one that's the most intuitive by returning that renderable on the main thread once it's done loading. And then lastly, you're going to pass that renderable from your model renderable to your node. You just add the node to the scene here with the AR scene view scene being that root node, and set the renderable, and that's going to render your object on screen. So like I mentioned, it's based off of a high-level scene graph API. I would say it's more like a tree in that there's one node that everything derives from, and that's pretty much the practice that I've been using and seeing others use when utilizing augmented images and just any AR experience that they're building, even if it's not related to augmented images. So that being said, let's dive into setting up augmented images. So there's going to be 3 dependencies that we're going to want to use. The first being ARCore, and then we're going to use SceneForm because it's native. And lastly, I'm just going to throw in the plugin as well because it's an asset viewer that you more than likely are going to want to use if you are doing any type of heavy AR work. So including this into Gradle is pretty simple. We're all familiar with including a dependency inside of Gradle. Next, you're going to want to add your SceneForm dependency. So This one is kind of tricky, or not really tricky. You're just going to need a little bit more for scene form. For instance, you're going to need a minimum SDK of 24. You can't do anything lower. So if your app supports anything lower than that, then you might want to check something else. Sceneform does use Java 8 language constructs, so you're going to need to add the source and target compatibility versions of Java 8 to your compile options block. And then lastly, of course, it's using ARCore, and there's two different dependencies that you can use for Sceneform. There's going to be the Sceneform core dependency, as you can see here, and there's also the Sceneform UX dependency. The UX dependency is the one that includes the AR scene view and the AR fragment, so that's the one we're going to be focusing on. But the AR or the Sceneform core dependency is just as good as the UX one. It just doesn't include those. It still has a lot of support for you to build your AR experience. And next, we're just going to do the Sceneform plugin. So you can find this inside of your plugin browser. Just Google Sceneform tools, and you should find that. Hit install, restart your Android Studio. And then the next step is going to be adding these two lines to your to Gradle file. So in your project Gradle file, you're going to want to include the class path of the plugin. And then in your app build.gradle, you're going to want to just go ahead and do the apply plugin like we're familiar with. So there's this function down here, sceneform.asset, which is very important in that it is the reason why you can actually view assets inside of Android Studio using this plugin. So you are going to have to do this for each of your models. If you have, let's say, 10 models, you're going to need to define this function 10 times or use this function 10 times. That specifies where the files are and the file and where you want this to go as far as rendering this object inside of Android Studio. If you don't do this, you won't be able to see the object inside of Android Studio or edit it. So keep in mind that. And then the manifest is going to be the last part of just setting up this augmented image experience. So use this feature. I'm just going to talk through this stuff in very simple terms. So we're going to need to make sure that the camera that the user's device has supports AR. Next, we're going to need to make sure that we can actually use that camera with the user's permission tag. And then lastly, the metadata here is just telling Google about our app, essentially. The main thing that I've seen this be used for is that it categorizes where or how Google recommends your app to others. So it'll group your apps in the Play Store with AR-related apps if you set it as required. It does also have kind of like secondary effects in that if you do set it to required, then if the user denies, updating their ARCore version or anything like that at any point, then it's going to close your app. You can set it to optional, which of course, I think that's probably going to be the most common. I would recommend using optional if your app is not strictly AR related, and it's just an additional feature that the user doesn't necessarily have to use. So definitely keep that in mind. And now we're going to be able to use ARCore and the Sceneform plugin as well as Sceneform. But there's one more thing that comes with the ARCore SDK, and that's going to be the ARCore image tool, which is a command line tool that allows you to take a set of reference images and generate an image database file. We're going to talk about an image database file in a couple slides from here, but it's a very important step when it comes to doing augmented images. And the last bullet point where it allows you to score your reference images, that's super important, and I would recommend you always do this with any reference image that you use when you're creating an augmented image experience, because it's going to greatly affect how well your augmented image experience is. So let's talk about how ARCore is able to allow us to develop augmented images. So in my experience, I feel like I've narrowed this down into 3 key steps. So the first point, you have to tell ARCore what images to look out for by building an image database. And then once you do that, if you add an update listener or when you add your update listener to the scene, it's going to be constantly calling back to your code. So ARCore is constantly scanning to see if any of the images that you've told it to look out for are visible through the camera. And then lastly is pretty face value. When a match is detected from the image database, ARCore is going to render that object on screen. So you're going to have a lot of control over steps 1 and 3. So keep that in mind. Even allowing you to teach ARCore what angles should qualify as the same image, and even determining like what is going to determine what a match is. So how does ARCore learn what to look out for? I mentioned an image database, and you can create an image database in many, many different ways, and they all have their pros and drawbacks or whatnot, but you can utilize the ARCore image tool, as I mentioned before, to kind of do this beforehand. This is going to save you a lot on performance, especially if your app is very heavy with AR. Or you can do this dynamically with code, which I would recommend doing it like this if you're not doing an extensive AR experience. So I just added 2 different ways to kind of do this just to show its flexibility. So you can deserialize from an input stream and have an augmented image database, or you can use, or you can construct it just, like you would any other object. And I'm also adding an image here because I wanted to point out this width in centimeters. So this is not something that's super obvious when using an augmented image database, but if you provide a path, or if you provide a size, an expected size of the image that you're looking out for, it's going to optimize your augmented image experience a bit because ARCore will already know what to look out for. So we're actually going to talk about that a little later when I give my tips or whatnot. So that being said, after it knows what images to look out for and the AR scene is initialized, it starts scanning for images to track. So when you're tracking, this is pretty much the gist of your code. I mean, obviously, depending on your AR experience, it could be a lot more robust than this, but this is essentially what you want to do. So you're going to want to add an update listener, and then in that onUpdate function where it's constantly calling back, you're going to want to make sure that you get this list of augmented images. So ARCore can track up to 20 images at the same time, but it cannot track duplicate images. So what that means is that you can ensure in this augmented images list that each one is going to be unique. You're not going to get 20 of the same augmented image essentially returned back to you. So each augmented image in this list is going to have a little bit more information for you to actually use if you want to do any type of further processing at this point. So I just wanted to show what the guts of this looks like. Again, you may use this, you may not. It all depends on what your experience is. But what I've realized is that the name attribute here is probably going to be one of the most important attributes when you're using this augmented image object, mainly because this acts as an identifier most of the time. It doesn't have an ID or anything, but you're going to use this as an identifier when you are verifying your image here. So I wrote some code here and highlight this Andy image constant just to kind of show you what role the name plays in the whole flow of creating an image database and adding an image and verifying if this image is the image that is being tracked that ARCore is returning to us. So as you can see here, we've already talked about most of this stuff, but the Andy image name is being used when we're adding an image programmatically here. It's going to be the name, whatever name you use to add the image is going to be the one that is returned inside of that array list. And then down, if we just jump down below, this augmented image name equals Andy image name. We know that this obviously means we're just checking to see if this is the same image. And if it is, now we can render this object on the screen. So the rendering step is a lot. I mean, all of this is pretty simple, but the rendering step is fairly simple in that you just create a node and you just set the renderable to what the augmented image is because it isn't a renderable in and of itself. And then you add that child to the scene, and now you have this augmented image experience. So going back a couple steps, what this means is that if we look at the Google example again, we can kind of see, let's see if I can jump back here. If we look at this Google example again, then what we'll see as it's doing this right here, so Right now, ARCore has just picked up that it's tracking the image. It looks kind of fancy because there's a fade animation, but you can kind of see this frame jump around a bit. And when ARCore has detected this image, then we see, I'm just going to go back again, this augmented image rendered again. And you can see that when the frame pops into view. It's very subtle, and this is a very, very good example of an augmented image, but it's just these 3 steps happening exactly how I showed before. So that being said, just get back here. Okay, so one thing I do want to point out, though, is the node. So there's many different variations of nodes that you can create yourself, but the one that you probably will be using, this is not the one that you will more likely be using. This is just, for example, this is the very base node, but the one that you're more likely want to look into is called an anchor node, which allows you to set the position of the node inside of the, I'm going to say inside of the scene, but really you're going to be setting nodes inside of nodes, and it's going to be relative to the parent node. So the scene is going to be the entire virtual world with 0, 0, 0 representing the center of that. And then, of course, adding a node to that and then adding a node inside of that is going to determine what is going to be the coordinates of, the positions of that node. So ARCore is pretty smart in that it knows the extent of your objects. So if your object is, let's say, 5 meters by 5 meters, then setting it to 0, 0, 0 is going to set that node inside of that 5 by 5 by 5, or 5 by 5 by 5 node, rather than just setting it in the center of the scene itself, which could be huge. So that's going to complete the augmented image flow. This experience can range from rudimentary to robust. I would consider the Google's example very robust. And it really just all depends on your 3D objects itself and, of course, the animations and things that you add on top of that to make sure that it looks pretty good. So I want to share with you some tips that I've learned from doing augmented images. And, one thing that's super important is that each database stores a representation of the reference images at about 6 kilobytes. So couple that with the 1,000 image limit that augmented image databases have. And you just want to make sure that you manage the creation you want to manage the creation and managing of your augmented image databases, because as of right now, you can't delete them. And you can't delete them for an AR session. Don't keep any unused images inside of your your augmented image database because this has a slight impact on performance. And only one image database can be active at a time. So what this essentially means is that if you're initializing multiple augmented image databases, the previous one that you were using, all of the augmented images inside of that were being tracked is going to have a state of stopped or paused, and you won't be able to do anything else with it. So only one at a time. It takes about 30 milliseconds that I've measured to add one image to an image database. So you can do this on the main thread, but obviously for performance points, you more than likely want to do this off the main thread when you're adding your images. Or even better, use the ARCore image tool to create your image database beforehand. That way you can just remove that factor out of the whole runtime experience. If possible, specify the physical size of the image. That's what I did inside of that add image within centimeters. If you can specify the physical size of the image, it's going to improve the tracking performance of the augmented image experience itself. You're going to want to make sure that when your user is trying to track an image for the augmented image experience, that it takes up about 40% of the screen, because if it doesn't, it's going to be really hard for ARCore to kind of try to track that. You can use what's called fit to scan. It's an image provided by Google. It's essentially like a frame, a lot like the QR code frame that you're familiar with seeing, where it has a little box to ensure that there's a certain size that image has to be for it to track. And ARCore cannot track multiple images. It cannot track moving images. So don't base your AR experience off of anything moving, doing anything in a car or anything like that, because all of your augmented images are going to have a state of stopped, or they're just not even going to be tracked in and of itself. And I would say that using multiple variations of the same image has helped me a lot. For instance, what I mean by this is that if you have, a picture of Andy from one angle, and let's say you have a picture of Andy from the top where Andy doesn't really even look like the same object from the top, ARCore doesn't know that. So if you have reference images of Andy from different angles, then ARCore is going to be smarter in picking up that that is going to be, the same object essentially for you to render. And as far as best practices are concerned, ARCore for augmented images takes PNG and JPEG, but you're going to want to avoid heavy compression with this. That being said, increasing the resolution of your reference images does not do anything for you. So a 1,000 by 1,000 image is not going to do anything but bloat your app essentially. Also, images should be flat. They should be 15 by 15 centimeters. I mentioned that it's really good, or it's a really good idea to do something like this with product packaging. That is with the assumption that the package is a box and that the label is flat or that the image is flat. You can't do anything that's wrapped around a can or like a beer can or anything like that. So kind of stay away from that. Make sure that it doesn't have wrinkles as well to improve your tracking ability. And detection is going to be based off of high points of contrast. So you can use black and white photos, but all you really want to make sure is that there's a lot of contrast in that image in and of itself. Homogeneous images do not work well. So images that are mainly white, images that are mainly black, or any color in and of itself, they're going to have a really, really low score when it comes to the reference image score, which it's really hard to actually spot a really good reference image for humans. But for the ARCore image tool, it's a lot easier. So I mentioned that the ARCore image tool, one of the best features about it is that it scores your reference images to kind of tell you if an image is good for a reference image or not. I would recommend a score of about 70 or above. That's where I've seen kind of like a jump from not really tracking or being spotty with tracking to tracking really well. Of course, 100 is going to be the best, and the score is between 0 and 100. So here's two examples of what a good reference image is and what a bad reference image is. So the world here, or the Earth, it obviously has a lot of unique feature points, and rarely does any feature point look like another. So this gets a score of 100 from the ARCore image tool. This picture of this building here with all of these windows that look the same, and it looks the same all around in and of itself. This gets a score of 0 because of the repetition and the lack of contrast. And that being said, that's going to be the conclusion of my talk. So hopefully now you're informed enough or emboldened to go about and create your own augmented image experience. Definitely adhere to the tips and the best practices that I've mentioned, and you should be good to go, create something really impressive. Thank you.